Now just I give you some important notes before to start. The exam will be easy, inshallah. Start the exam with extended questions. Take a break about 5 minutes after half of the extended questions. For example, if the extended questions will be 8 questions, after 4 questions, take 5 minutes break. Pray to God. Pray and ask God to make the exam easy for you. Remember, your success does not depend only on your status, but also on the prayer of your parents. Do not stay up late today and take enough time to sleep. Do not solve difficult questions today, but practice on the solved questions. If you have any questions, send them to me. I will be with you all the day and tomorrow from 6 a.m. Now, when you open the exam paper, you will find here draft paper, مسودة. We go direct to the draft paper. This is the way of open the exam. Okay? So we will go direct to what here? To the draft paper, مسودة. In that draft paper, when I enter the exam, maybe I memorize something and I don't need to forget that. Just the important notes. You can write anything in the draft. For example, if you memorize a definition and you before the exam and you don't need to forget that, then write the definition. With pencil, with pen, no problem. The draft is a paper for you. You can write anything inside it. Then we go to the draft, the last paper. For example, we check important notes. About here, the big value, this is about alternating current. We do that revision, quick revision about what here? About number 1 here, peak value. Okay, so what do we mean by peak value? Peak value is the maximum value. Peak value of the voltage denoted by V node, for the current denoted by I node. That are the maximum value, peak value. Number 2, RMS, root mean square, RMS, equals I node divided by square root of 2. And VRMS equals V naught over square root of 2. Number 3, the average or the mean. The average or the mean value denoted by this symbol. So now remember, the average current is 0. The average alternating current is 0 because the current varies from positive to negative. And also the average voltage, alternating voltage is 0. Now, number 2, the average power. The average power, it is the half the maximum power. Okay, now. So it's equals to half multiply I naught is the maximum current, multiply V naught maximum current. Or the average power equals I RMS multiply V RMS. Number. And remember the relation between the voltage and the current. Ohm's law. So the first triangle in Ohm's law is that V equals I times R. And V naught equals I naught multiply R. And also V RMS equals I RMS multiplied by R. Okay. Next, number 4. I equals I naught sine omega t. And remember, the angle must be in radian. So if you need to solve a question in this part, you have to convert the system to radian. Also, V equals V naught sine omega t radian. What is omega? Omega, it's 2 pi over t. So omega, yeah, omega, it is the angular frequency. It's, okay, 2 pi over t. This is omega, or 2 pi f frequency. The frequency equals 1 over time t. And remember, in case of capacitor, okay, capacitor, charging graph, charging capacitor, graphs. We have 3 graphs, you have to remember them. Number 1, number 2, number 3. This is QT graph, this is VT graph, and this is IT graph. In case of charging, the graph going up increases with time. Voltage increases with time. But in the current, decreases with time. This is a charging. What about discharging? Now we have 3 graphs, Q, T, and here V, T, and I, T graph. In case of discharging, the graph going down, decreases with time. All of them. Next, we have to memorize the formula. Q equals Q naught E to the power negative T over RC. RC is called the time constant. And V equals V naught E power negative T over RC. And also the current. Okay? Very important part when we say Q equals Q naught E power negative T over RC. Take len both sides. So len Q equals len Q naught plus, when we take len, it becomes negative T over RC. Rearrange this formula, then len Q equals negative T over RC, I can write it as 1 over RC multiply T, plus len Q naught. This equation looks like Y equals mx plus C. When we represent the relation of len, this is len Q, and this is the time T. We will get a straight line has negative slope. This point, the maximum point, is y-intercept, which is len Q naught. The slope of this line, or the gradient, the slope, equals negative 1 over RC. So RC from the graph equals negative 1 over the slope. The slope is y2 minus y1 over x2 minus x1. Second, you have always to look at the formula sheet. So this is the beginning of the exam. Yes, question? Which speech? What do you mean by speech? Okay. My voice is clear, guys? Yeah. Now we go to what? To the extended question. Okay, of course, the exam in front of you. We go to the extended question. Let us, we go back to the extended. The first question is easier for me. You can choose any question. Now, I start the exam with the extended question. Question number 15. Start to solve with me, please, first. I give you 2 minutes or 1 minute to solve the question. Start. And if you solved it before, check your answer with me. Define the electromotive force. The energy transferred by each coulomb that passes through a source of whole circuits. So I write this definition here. Energy transferred by each coulomb that passes through a source of whole circuit. Okay, so this is here the definition. Yes. Okay. Now, next part. He said in the circuit below, so I advise you to write the givens of the question. Circuit below here. Okay. When the switch S is open, the reading of a meter is 0.25 ampere. When the switch is closed, okay, the reading of a meter is 0.45 ampere. Using Kirchhoff's law to prove that the current passing through R1 and R2 are equal when the switch S is closed. Then we solve this part and we have to use what? Kirchhoff's law. Then this one is closed. So what about the current here? Of course, the current from the circuit, it's from positive to negative. So now this is the current I from the source. This current divided into I1 and I2. Now he said S is closed. So when S is closed, the reading of a meter is 0.25. Now, let us resolve this question. We need to show that I1 equals I2. We take a loop. This is loop 2 here, this loop. Now we take the loop BC, we say we take the loop because we need to use Kirchhoff's law. Loop, okay, here, B, C, D, E, B. Now, in the Kirchhoff second law, if we have the current in direction of loop, the resistor will be negative. So negative I2 multiply R2. And now here we have negative, negative, double negative. I1 multiply R1, it's equal to 0. So negative 8 I2, because R2 equal 8 and R1 equal 8. Negative, negative is positive. R1 is 8, equal to 0. Shift negative 8 I2 to the other side. Then 8 I1 equals 8 I2. Cancel 8 with 8, so I1 equals I2. So we proved by using Kirchhoff's law that the two, okay, we proved using Kirchhoff, the currents are the same. Now, find the EMF, one question. Yes. Yes.
Mister,
Yes,
can we
Adam.
use Kirchhoff first law?
How? I equals
because
I1 plus I2, but we need to
yes,
show that I1 equal I2.
yes, Mister. By using Kirchhoff first law, we can deduce that when it's closed, the emitter reads 45 ampere. Means it has both. So this is I, and I1 or I2 is 0.25. So we minus 0.
Why? Why? Because the two resistors are equal. Some we can accept this, no. Okay, but you have
Okay.
to mention that because R1 equals R2. Yeah. Now, next they said, okay, thank you, Adam. Find the EMF when the switch is closed. Now, first of all, when the switch is open, what will happen here? So this is the first part. When S, okay, open. When S is open, so just we have one resistor and one EMF. When S is open, the EMF here is 0. Okay, here, when S is open, the current is 0.25 when S is open. Now, when S is open, we use the formula E equals I R capital plus R small. In this part, we have one R capital 8. So EMF equals the current 0.25 multiply R capital is 1 R8 multiply R small. This is one equation. Now, when S is closed, also EMF equals I R plus R. But now here we find R total. What is R extended? Because they are connected in parallel, it's 1/8 plus 1/8 all to the power -1 equals 4. Then the EMF equals I when S is closed, it's given 0.45. And now R capital is 4 plus R small. This equation number 2. Equate 1 and 2 because the same EMF. So 0.25, 8 plus R equals 0.45, 4 plus R. From this, you can get R. R, it will be 1 ohms. And then you can get EMF by substitution in the equation. So it will be 0.25. When we use the first equation, it's 8 plus 1. From this, EMF equals 2.25 volt. Check your answer. Now, next question. Uniform copper wire of 1 meter length. So the given in that one is the length of the wire. So the length of the wire, this is given. Cross-section area must be in meter square, already given. And the number of density, it means N small. The current, 1 ampere. Calculate the mean drift velocity. We need V. Remember, I equals N A EV. You can draw a triangle like this if you need to get anything. Yeah. So this is I, and down it's N A E V. Now, what do we need in that one? We need the drift velocity V. So put your finger on V. So V equals the current up in the numerator over all of them down in the denominator. N A E. Just we do substitution. So it's a direct question. I equals 1 ampere over 8 multiply 10 power 28 multiply the cross-section area 5 times 10 power -7. E is the charge of electrons, will be given in the exam 1.6 times 10 power -19 coulomb. So multiply by 1.6 times 10 power -19. When you use the calculator, the answer becomes 1.56 multiplied by 10 to the power -4. The unit is meter per second. The average value of the drift velocity in most questions between -4 to -6 will not be more, because actually the collision between the electron and the atoms and the collision between the electrons together, so the drift velocity is very small. How much time needed for an electron to move from one end of the wire to the other? Here, this is the length of the wire, and the electron starts from one end to the other with drift velocity V. We know that the velocity equals the distance over time. Then when you rearrange, the time equals the distance, which is L. So this is the distance traveled by the electron, L, over the drift velocity. L is 1 meter from the given. Then the time needed equals 1, the length of the wire, divided by the drift velocity, 1.56 times 10 power negative 4. By using the calculator, you will get 6.40 multiply 10 power 3 seconds. Okay, next question. Now, this question about Kirchhoff's law. I choose a hard one for Kirchhoff's law. This is little hard. Now, state Kirchhoff's second law. Sum of EMF in a closed loop, in a closed circle or loop, is equal to sum of potential difference. Find the values of E1 and E2. Now, how can we solve this? Follow me, please, to solve the question about Kirchhoff's law. First of all, we have to put the direction of electron flow. The direction of electron flow, it's from negative to positive. So this is the electron flow here. And this is the electron flow. This is the first step. This is the electron flow. It's from negative to positive. Second, look at the direction of the current here. But before this, you have to decide where are the junctions. A is junction and D is junction. Only A and D are junctions in that circuit. The junction is the point of connection of wires. Now, what about the current here? 1 ampere, this is the direction. So in this branch of the circuit, it's 1 ampere, 1 ampere. Start from one junction, ending at the other junction. So 1 ampere starts at D and ends at A. This is 1 ampere. 2 ampere start at A and go in this direction. Can you see? Goes in this direction. So this is what? This is I2, 2 ampere. So this is 2 ampere, 2 ampere, 2 ampere. And the first one is 1 ampere, 1 ampere, 1 ampere. Now the current in is 1, but the current out is 2. Not possible, because Kirchhoff's first law states that the sum of current in equals out. We have here branch. Now, at branch DA, at the line DA, the current in or out? Oh, it depends on the logic. The current in is 1 ampere and the out is 2. Then the current here must be in. Now, let the current is I, and it is in, of course. We're starting the solution, we say at junction A. Now we apply Kirchhoff's first law. The sum of current in, 1 plus I, that are the currents in, equal the current out, which is 2. Rearrange the formula, I equals 1 ampere. Then the current in this branch is positive, it's 1 ampere. So this is 1 ampere. Next step, the loop. Of course, the loop depends on which value of EMF is more. 20 volt is more. Then we take this loop. Loop 1. Now we apply loop 1. So we take loop 1. Why we take this direction? Any direction is correct, but it depends on the maximum voltage, 20 volt. Then this is the good direction. Then we apply Kirchhoff's second. We say loop 1. Now, we're starting with a point and ending at that point. But there is one question here. Yes? Yes, of course, you can draw because it is exam paper. Draw with pencil, my friend. This is very important, Yahya. You will solve in the graph paper everything on the graph will be accepted as a part of solution. Don't worry. It's like me. You will do exactly the same as I saw. This is a model of solution. Loop 1. Now I start at this corner. Now we go together here. It's okay. Can you see here? I go in this direction. Now we find 6 ohm resistor and the current is 1. If the current in the same direction of loop, it will be negative. So it's a negative 1 multiplied by 6, negative IR. The direction of loop is the same direction of electron flow, so it's a positive 20. Now, the resistance is 1 ohm and the current 1, the current in direction of loop, so it's 1 negative, negative 1 multiplied. Now, we go on this. Now, can you see here the loop? Now, the loop in opposite direction of current, so we have to put double negative. The current is 1 ampere. Then it's negative 1 multiplied by 4. Also here, it's opposite. The current is opposite in direction of the loop. Then it's a double negative also, negative 1 times 1. The electron flow E1 is opposite to direction, so it's a negative E1. We reach the starting point equals 0. Yes? Not answer? Yes? Question? Yes, my friend?
هذا ليش هون الريزستنس نيجاتيف؟
You solve with any way of solution, but that way I used already to my students. But use any way to solve.
Okay.
I said that, my friend, in case of resistance, remember this, if the current in the same direction of loop, it's negative IR.
If not, we put positive.
Yes, if it is
Okay.
opposite, we add another negative, because opposite in physics means a negative. We double negative because if the current in the loop is in opposite direction of the current in the circuit. Okay, now we calculate this by using the calculator. You will get here negative, okay? We calculate this by using calculator. Okay, I think negative 6, follow me please, plus 20, just to check our answer, minus 1, plus 4, plus 1, equals 18. So 18 minus E1 equals 0. Shift E1 to the other side, then E1 equals 18 volt. Now we need to find E2. Another question? Yes? Mister, why did we make resistor negative? Because this is a rule in Kirchhoff's law. Because actually comes from what? The sum of EMF equals the sum of potential difference. Again, the sum of EMF equals the sum of potential difference. So E1 plus E2 equals IR1 plus IR2. This is the rule. When you shift all to one side, you will get E1 plus E2 minus IR1 minus IR2 equals 0. So the resistance is negative. Okay, now we need to find E2. Then we go to the second loop. Now we take this direction of loop. Okay, here we take this loop, loop 2. Okay, now we apply loop 2. We start with a point, for example, the point D, and then we go through this point. First thing, E1, it is in the same direction of electron flow. Electron flow is the same direction as the loop, so it's a positive E1. Now, here, the current is 1 and the resistance is 1. It is in the same direction, the current in the same direction of loop, so it is 1 negative, 1 multiply 1. Another negative 1 multiply 4. And then we go down, negative 2 multiply 1. E2, it is in opposite, so it's a negative E2. And then 2 multiply 2, it's a negative because it's a resistor. 2 multiply 2, finally equals 0. Already we got E1 before, it was 18. We substitute for E1. Then 18 minus 1 minus 4 minus 2 minus E2 minus 4 equals 0. We calculate the values here. 18 minus 1, minus 4, minus 2, minus 4 equals 7. So 7 minus E2 equals 0. Shift E2 to the other side, then E2 equals 7 volt. This is a little difficult question about Kirchhoff's law. Now, next question. Yes. This is about a potentiometer. Now, read the question, be careful. And then this is a hard question. Okay, he said, now read the question. A potentiometer circuit is used to determine the unknown electromotive force. Now, just we focus on the important points here. Here. Okay, now we need to find, the EMF of the cell X. So this is the required. In the circuit shown, E is a cell with an EMF. It is known accurately. So already we have the value of EMF of E. QR is a potentiometer wire which has movable contact S to get the balance point. The contact S is connected to galvanometer and to the cell X. Now, look please, which is not necessary. We don't need it. Requirement to determine EMF of X. The EMF of X must be lower than, yes, this is must be. This is necessary. And the length of X, the QS and the QR must be determined accurately, yes. The internal resistance, no. This is we don't need. This is not necessary to need. Then the answer here is the second part. So not necessary for this. Okay. Remember the formula that X over E equals the length of balanced QS over QR. This is the formula for potentiometer. Now, next question. Here. What is the function of potentiometer in the circuit? Of course, to comparing potential difference. This is one of uses. So we write here one of function, comparing potential differences. Now, next question. Take care of that question, please. We read it, be careful. He said, a cell of EMF 1.2 volt. This is the cell down. Connected to the circuit here, as shown in the figure. The connection B is moved along the wire XY. The galvanometer reading is 0. This has a balance point. When the distance XB is 0.3. Now XB, this is length, is 0.3 meter. The current in the circuit, so this is the current here, the circuit current. It is 2 ampere. And the resistance R is 0.75 ohms. Okay, now, what is the first step here? We can get the external potential difference by using EMF. So we can write here EMF equals V plus IR. Okay. Rearrange the formula. So V, it means the terminal voltage, the voltage outside the battery that we use it. So it is EMF minus IR. So the terminal voltage equals 4 minus the current is 2 and the internal resistance is 0.35. When you use the calculator, it becomes 3.3 volt. Now, what about the voltage dissipated by R by using Ohm's law. V equals I times R. So V through the resistance R equals the current, which is 2 over 0.75. It will be 1.5 volt. Then we can calculate the voltage that we will use according to XY. So the voltage according to XY, this is VXY, VXY. Of course, it is not possible to use the red pen in the exam, just the blue or pencil, but because I explained. So VXY equals V total minus VR. V total, it was 3.3, the terminal voltage, minus 1.5. When you do this by the calculator, it becomes 1.8 volt. Then this V according to XY, we have a relation between the voltage and the resistance. It's direct when the current is the same. Now, here we say VXY, yes, question? Yes. VR equals 0.7 divided by 2. Why? No, it's 2 divided by 0.7, not 0.7. It is V, V here, V equals, V here, sorry, thank you, here. Thank you for this, sorry for that. V equals IR, thank you. V equals I times R. The current is 2, sorry, thank you, 0.75. So it is 1.5, thank you, yeah. Okay, yeah. Thank you. Now, Vxy is 1.8. We apply the potentiometer formula. Potentiometer formula is that the voltage here, Vxy over Vxb equals the length related to xy, which is the total length that are required, over the length in a balanced point, according to Vxy, which is here, Vxb, which is xb. Now, Vxy now is 1.8. And V according to xb, 1.2 when the point is balanced, equals xy is the required, divided by xb, which is given 0.3. From this, we can get the length of xb. So xy equals the cross multiply 1.8 times 0.3 divided by 1.2. The answer is 0.45 meter. Okay, so this is the answer of this little hard question. Next question. State Ohm's law. Here you have to say conductor and you have to say constant temperature. So we write for a conductor, at constant temperature, the current is proportional directly to the potential difference. Now, question. I said a fixed resistor and the diode are connected in series. Electromotive force is 6. Okay. No internal resistance here. The graph shows the variation with potential difference and the current. This is the graph of the diode, for diode. Now, write the way of connection of the diode. We have two ways of connection of diodes, forward and reverse. So this is forward because the current pass here. Reverse, the current will not pass. So, or little. So it is forward biased. Forward biased. Now, describe, okay, the qualitatively, qualitatively, the variation of resistance of the diode as V increases from 0 to 1.25. Now, from 0 to 0.6, the resistance is very high. From 0.6 to 1.25, the resistance decreases gradually to be very low. Again, question? Yes? Yeah. So, again, the backward, okay. Biased. Here, this is the direction of current, my friend. Here, this is the current. Okay, can you see? So it is forward biased. Forward biased. Reverse, if we flip it like this. Okay, so if the current like this, it will be reverse. Okay, is it clear? Yes, any other question, please? Yes. Yeah. Yes. Direct message. Yeah. Okay, now. Just 1 minute. Just 1 minute, please, because I connect something. Okay. Describe, I said here, from 0 volt. So we write here, from 0 volt to 0.6 volt, the resistance is very high. The resistance of diode is very high. And from 0.6 volt to 1.5, 1.25 volt, the resistance is very low. Okay, the resistance is very low. Okay. Okay, now next question is said the current in the diode is 40 milliampere. What is the resistance of the fixed resistor? Now, we need the voltage of the diode when the current is 40 milliampere. Here, the current passed through the diode is 40. Now, we draw a horizontal line here. So, when the current here is 40 milliampere, what is the corresponding value of the voltage? We go down. This point is 1.25. Then this point approximately it's 1.2. So the voltage of the diode is 1.2 volt. Why we calculate the voltage? To find the voltage of the resistance. Then, right here from the graph, okay, the voltage of the diode equals 1.2 volt when the current is, when I equals 40 milliampere. Now, we calculate the voltage of the resistance. The total voltage of the circuit is 6 volt. We take away 1.2, so 6 minus 1.2 equals 4.8 volt. Then we can get the value of the resistance. R equals V over I. V is the voltage, which is 4.8, divided by the current in ampere, which is 40 milliampere, 10 power negative 3. By using calculator, it will be 120 ohms. Okay, so the resistance is 1. Yes, question? No, 1.3 for what? 1.3 the way. Yes, no problem. Less than, but here 1.25 at the middle, my friend. So not possible. This is at the middle. It's 1.25. So the value must be less than 1.25, not more. Because each line here is 0.25. Okay? So no, not possible. Next question. Now we go to the next question. Read the question with me. I said a capacitor of capacitance 330 microfarad. We write the given. This is the way, okay, the way of reading. Here, this is the capacitance C. It's in microfarad. We can convert to farad, multiply by 10 power negative 6. Charge it to the potential difference. This is V. It is then discharged through a resistor of resistance. This is R. It's in kilo ohm. To convert to ohm, multiply by 10 power 3. Calculate the energy stored by the capacitor when it is fully charged. We have capacitance and voltage. Then we use the direct formula. The energy stored equals half C V squared. Now, C, it must be in farad. So the capacitance in farad, because to get the energy in joule, so it's 330 multiply 10 power negative 6 to be in farad. And the voltage already in volt, then we do substitution. It's a half multiply 330 multiply 10 power negative 6 multiply 9 squared. By using the calculator, it becomes 1.34 multiply 10 power negative 2. So this is the answer of this part. Okay. Now, the time constant denoted by T capital, which is R multiply C. R is the resistance in ohm. C is the capacitance in farad. R equals here 470 kilo ohm. We have to convert to ohm, multiply by 2. The capacitance in farad, 330 multiply 10 power negative 6. By using the calculator, T equals 1.55 multiply 10 to the power 2. This is time, so the unit is second. Now, next question. The potential difference across the capacitor 60 seconds after discharge. In discharge, we use the formula exponential. V equals V naught e to the power negative T over RC, the time constant. What is V naught? It is the maximum voltage, the voltage of the battery, 9 volts. Okay. What is T small? It is 60. What is RC? It is the time constant, 1.55 times the 10 power 2. Then we do substitution. So it is 9 multiply E to the power negative 60 over 1.55 times the 10 power 2. By using the calculator, it will be 6.11 volt. Okay. Now, next. I said the configuration in the figure below shows identical capacitors. Each has capacitance C. Calculate the combined capacitance. He will ask you about the combined capacitance without numerical values. Why? Because you need to check, do you understand the way of solution or no? Now let us do this. First, you have to remember the connection of capacitor is opposite to the connection of resistors. Resistors in series we add. In parallel 1 over, but here is opposite. So capacitors in series 1 over. I advise you to solve it step by step. So first, we find the C total of 2 and 3. They are in series. So it's 1 over C plus 1 over C, all to the power negative 1. 2 over C, all to the power negative 1. Flip it because the power negative, C over 2. This is T2. Now, C4 5 and 6, they are in series connection. So 1 over C plus 1 over C plus 1 over C, all to the power -1. The same denominator C as the numerator, 1 plus 1 plus 1, 3. All to the power -1. Flip it, so it's C over C. Now we can calculate C total. They are connected in parallel now. So C total equals C1 plus C2 and 3 plus C4, 5, and 6. It means C plus C over 2 plus C over 3. Take C common factor. Then it's 1 plus 1 over 3 plus, 1 over 2 plus 1 over 3, all multiply C. By using the calculator, 1 plus half plus third, it's 11 over 6. Then the answer is 11 over 6. Do not forget to write C. Okay, this is the answer. Next question. Now, this is about the capacity. This is important question. Take care. Now, let us solve this question. He said, if the potential difference of a capacitor is given by V equals, and the following graph represented the relation between len V and T. If the resistance is 10 ohm, so this is R, it's 10 ohm. Use the graph to determine the capacitance. Now, okay, remember the way. Yeah. We know that V equals V naught E to the power negative T over RC. If you take len, so len V equals len V naught minus T over RC. Rearrange -1 over RC multiply T plus len V naught. Then the slope of the line equals -1 over RC. It means RC equals -1 over the slope. Then we find the slope first. What is the slope? Y2 minus Y1 over X2 minus X1. Let me go back to the graph here. This point, X1 or the time, it's 10. And Y1, it's 2.2. And this point, X or T, it is 67.5. And Y is 0.9. Now, this is X1, Y1. Okay, this is X1 and this is Y1. And this is X2 and this is Y2. Then we use the formula of the slope. Okay, yeah. So Y2, 0.9 minus Y1, 2.2 over X2, 67.5 minus X1 minus 10. By using the calculator, it becomes here negative 2.26 multiply 10 power -2. This is the slope. But what do we need? We need RC. Yeah. Now here we continue. So this one. Okay. Yeah. Now we say RC equals -1 over the slope. Negative 2.26 times the 10 power -2. Negative cancel with negative will be 44.2. The resistance is 10. So 10 multiply C equals 44.2. Then C equals 4.42 farad. Okay, guys? Now we take a break and we return back. It is the same like the exam. Okay? Take a break, 5 minutes, and then we will come back. Okay, we go to the next question here. This is about magnetic fields. Read the question with me. He said the figure below shows a beam of electrons that enter a region of magnetic field of flux density. So this is B. So the given is B. The electrons. So remember, the charge of electron is negative 1.6 times 10 to the power negative 19 coulomb, and the mass of electron 9.11 times 10 to the power negative 31 kilogram, given in the formula sheet. The electron travel in a circular path of radius. So we have here R, radius in meter, inside the magnetic field. Now, here, the question is that write two ways to producing a magnetic field, of course, using permanent magnet or using electricity in solenoid. So number one, using a permanent magnet. Number two, using an electric current. That are two ways to produce magnetic field. What is the direction of magnetic force that acts on the electron? Electron, take care, it's negative, okay? As enter the field. We use what here? Fleming, what? Fleming left, okay? Hand. Now, current, field force. Current, it means the velocity. So this is the velocity. Field, it is into the page. Okay, so this is the field. And now the force, it will be up. So the direction here, okay, the direction of force is up. If it's what? If it's positive. Fleming left-hand rule on positive charge. Because it's negative, we say it's down. Okay, so we write here the force, the magnetic force is down. Why? Because it's a negative charge. We write downwards. Yeah, this is the answer. Next question, calculate what here? Calculate what? The magnetic, okay, calculate the velocity of that one. Okay, let us do this here. Now, calculate the magnitude of electrons' velocity. Ready? Which formula we use it? It's already in the formula sheet. R equals mv over bq. Q now is the electron charge. When you do cross multiplication, so R VE equals mv. When you rearrange, so V equals R VE over the mass. Mass is the mass of electron. It will be given in the formula. Then V equals R is the radius in meter, which is 0.02, multiply the magnetic flux, which is 4.5 times 10 to the power negative 4.5 times 10 to the power negative 3 Tesla, multiply the charge of electron. Well, we don't put the negative here, the magnitude of it, okay? So it said the magnitude, okay? 1.6 multiply 10 to the power negative 19 coulomb, divided by the mass of electron, which is constant to 9.11 times 10 to the power negative 31. By using the calculator, the answer is 1.58 multiply 10 to the power 7, and the unit is meter per second. Okay, next question. He said, a uniform electric field strength is applied in the region of magnetic field as shown in the figure. Okay, calculate the value of it that make electrons be moved in a straight. It means without deflection. Without deflection. Without deflection, it means the velocity equals E over B. This is the rule. So the electron moves straight. Rearrange this formula because we need E. So it's V, the velocity, multiply magnetic flux density. The velocity already, we got it, and the magnetic flux density is given. So the electric field strength equals 1.58 multiply 10 to the power of 7, multiply magnetic flux density 4.5 times 10 to the power negative 3. The answer is 7.11 multiply 10 to the power 4. The unit is volt per meter. State the condition needed for the charge particle move in a circle. The charge moves in a circle if the velocity is perpendicular to the magnetic flux density. This is the condition. So the velocity is right angle. You can say if you don't need to write perpendicular. So is perpendicular to magnetic flux density. Magnetic flux density. This is the answer. Sorry. Next question. Here, you read the question. A particle of a charge positive Q and the mass M moves with a speed. So this is the speed. Uniform magnetic field out of the page. So the field here inside, it's out of the page. So this is the magnetic field. Already, this is given. The magnetic field inside this, it's out of the page here. Okay? It is positive charge. Now, we read, we have here the magnetic flux density, and we have the speed of the particle. Now, the magnetic field direction is perpendicular to the initial velocity. The magnetic field perpendicular to the initial velocity of the particle and perpendicular to and out of the plane of wave, like what I represent. Uniform electric field is applied in the same region. Now we have electric field applied at the magnetic field so that the particle pass undeviated, go straight. Now let us study the forces that acted on the particle by magnetic field only. Current, field, force. So it will be deflected down because what here? Because the magnetic force. Fleming left-hand rule. Now, to move undeviated, it must be acted by what? Another force. The electric force must be up. So the two forces will be equal. Then the magnetic force direction is upward. The magnetic force, sorry, the electric force is upward. The electric force takes the same direction as electric field. Then the electric field is up. So state and explain the direction of electric field. We say the direction. Of course, I write here, direction of force due to electric field is opposite, must be opposite to direction of magnetic force. Okay, so the electric field is up. So the electric field is up. Calculate the magnitude of electric field strength. Oh, it's the same way. Yes, question? Yes. The direction for magnetic force is always down. No, not always down. If we change the direction of magnetic field, if it is into the page, so the magnetic force, it will be up. No, this is not the rule. No, it depends on the charge of the particle and the direction of magnetic. Now, he said calculate the magnitude of electric field strength, E equals B multiply V. Here, I repeated this question. Sorry for that, because we already, I give you another question. -2 multiply 1.6 multiply 10 power 5. It was given. So the answer is 1.55 times 10 to the power 4 volt per meter. Now, he said the electric field is now removed. So only the magnetic field. So that the positively charged particle always follows a curved path in magnetic field. This arc is 4 centimeters. So R equals 4 converted to meter, 0.04 meter. Calculate the specific charge. Specific charge denoted by Q over M. It has value. Of course, this is not electron to say the charge is, no, this is just particle. Then we use the formula V over VR. Because already we have the value of V, the speed is 1.6, it's given 1.6 multiply 10 power 5 divided by the magnetic flux density, which is given also in the figure, it's 9.7 multiply 10 to the power -2 multiply the radius in meter 0.0. The answer is 4.12. Okay, multiply by 10 to the power 7. The unit is what? Coulomb per kilogram. Next question. This is about whole voltage. A current of 3.8. So the given is very important here. So the current is given I equals 3.8 ampere. This is the direction of the current. Now, this is the thickness, because we need the thickness. So the thickness denoted by T in whole voltage, 0.10 millimeter. We convert it to meter, 0.10 multiply 10 power -3 to be in. Free electrons per unit volume, this is N. We need N small also. Uniform magnetic field of flux density, this is B. Okay, calculate the magnitude of the whole voltage. Now, the whole voltage denoted by VH will be given in the formula sheet, VI over N, the number of free electrons per meter cube, Q is the charge of electron. We talk about here electron. Then B, it is 0.13, multiply the current, 3.8, divided by N, it's given 6 multiply 10 power 28, multiply the thickness, 0.10 multiply 10 power -3, multiply the charge of electron, 1.6 times the 10 power -9. The answer of this is 5.1 multiply 10 power -7, the unit is 4. Now, next question. Hall probe, which measures the strength of magnetic field, uses a thin strip of semiconductor rather than the metal. Explain why semiconductor. The number of free electrons in semiconductor is very small compared with the number of free electrons in the metal. And the whole voltage proportional inversely to the number of free electrons. So here N in semiconductor is less than N in metal. Okay, and the VH proportion, so VH in semiconductor is much greater than, or is very high compared to metal. Okay, compared to metal. For that reason, we use a semiconductor rather than the metal in whole voltage. Next question. Okay. A coil of wire is situated in uniform magnetic field of flux density B. Coil has diameter. Now we need the area, of course, because when we talk about coil and diameter, we find the area. Then, first of all, we find the area from this. The diameter denoted by D, 3.6 centimeter. Then R, the radius is half diameter. So it's a half multiply 3.6 centimeter, convert to 2 meter, multiply 10 power negative 2. And the area is by R squared when you use the calculator. So it's by R squared. R is given now. It's 1.02 multiplied by 10 to the power negative 3 meters. This is the area already we calculated from the first. The coil has, okay, and consists of 350 turns. So this is the number of turns in the capital, 350. The variation with time t of B as shown. Now, what do you notice about this? This is a straight line. So B varies in constant rate. So because B varies, then we have EMF. We have EMF E1 in the first line. In the horizontal line, the magnetic flux density does not change. No change in magnetic flux. It's a constant value. Then E2 in this part is 0. Finally, we have EMF again, but in opposite direction. In opposite direction to E1. This is number 1. And also, EMF equals delta B over delta T. Of course, delta BA. EMF equals N delta BA by delta T. Delta B over delta T is the slope of that line. Now EMF depends on the slope. Which line steeper than the other? This one, the first one. So this is steeper. So E1 is more than E2. E1 is more than E3. Okay? And E1, here's the time, is 0.2. E3 is 0.4, but the same height. Then what is the relation between E3 and E1? E3 is half the value of E1. Now this is the figure only. Just we study the figure. Now we need to answer the question. State for a Day's law. EMF induced is proportional to rate of change of magnetic flux linkage. Now, part B, he said what? Calculate the highest, okay, here, calculate the highest EMF. The highest depends on the slope, I said. For the steeper line, because the steeper give us highest induced EMF. Okay, line, the slope of that line equals the vertical change. When we go in this way, it will be here 45 on the line. But take care, it's in millitesla. Here, it is in millitesla. Can you see? Millitesla. And the time here in second. So the slope of this line, the vertical change is 45 millitesla divided by the horizontal change is 0.2. Then the answer is 9/40. Now, EMF maximum equals N delta B A by delta T. It means N multiplies the slope, multiply A. N already is given, 350. The slope is 9/40. Multiply the area, 1.02 times 10 to the power negative 3. The answer of this is 0.08 volt. Okay? So this is the highest EMF. Next question. He said on the axis of following figure, show the variation with time t. Okay? From t equals 0 to t equals 0.8. I said we have here three values of EMF. The first one is the maximum. Now we got it 0.08. The second one, it is 0 because it's horizontal. The third one, from the graph, it's half E1. So it's half multiply 0.08. It is 0.04, but in opposite direction of E1. Now we draw this figure. Okay. 0.8 each one line. So this is for the first 2 seconds. Then we draw horizontal line here. So this is 0.08 volt. And then from 0.2 from the graph, from 0.2 until 0.4, it is horizontal. It is 0. So from 0.2 to 0.4, EMF is 0. And then from 0.4 to 0.8, it is 0.04. Count with me. Okay, here. 1, 2, 3, 4. Here. It's okay. This is 4. But it contains all of this here. This is 4. Can you see? But in opposite, it's a negative 4. Okay. So this line here. Okay. This line. This is negative 0.04. Okay. So this is the relation between EMF and the time in second. Okay. Next question. Okay. Now read the question with me, please. Okay. He said the figure shows two identical bar magnets, A and B, drops from the same height through two conducting rings. Which magnet will pass through the ring faster? Now, this is according to Lenz's law. When that magnet moves down, then EMF induced in the ring produces magnetic field opposed to change. So this becomes a north. Can you see? So this ring becomes a magnet. Why becomes a magnet? Because the induced current reduced it, because the movement of the magnet A. So in case of A, when we drop current induced, this current produces magnetic field opposes the change. So it will be north, then it will be rebel the magnet A, so the magnet in position A moves slowly. What about B? Because here we have gap, can you see? This is gap. So this gap will stop the induced current. So no induced current in the ring, okay, B. So no EMF, so this magnet will go faster. Then the answer is B. Why? Because ring A will induce ring A will induce current I in it, reducing magnetic field oppose the change. But B has break. So no induced current. Yes, question? Yes. Yes, Matthew?
This I can
Yes.
explain by from the picture like we did.
Again,
This
for
now.
EMF? Yeah.
Yeah,
Now,
no, the done one for the magnet. I mean,
This
can I
part D or
explain this?
part,
Yeah,
part D or part E?
D.
Part
Like
D.
what
Okay.
you wrote, like I write B has like break that
Yes,
the
yes,
induced
yes,
current,
yes.
but
Yeah.
and I show like
Again,
the drawing you did.
This is, yeah. This here is Lenz's law. Lenz's law talk about what? if we have a coil, solenoid, and the bar magnet, north and south, if that bar magnet moves toward the coil, then what happened? EMF induced in the coil, producing a current. So this current induced because the movement of magnet toward the coil. This current producing magnetic field. So this is the direction of magnetic field. So if the magnet moves towards north, it will be north. If it's moving away, it will be south. To repel it, do not enter. To stop the movement of the magnet, oppose. This is what happened in case of A. In case of A, when the magnet moves out, if in the exam changes north to south, then also it will be south. It's okay, up. Then to repel it. So this is the way why in part A, the magnet will move slowly compared to part B. Okay? Is it clear, my friend? Yeah. Now, next question. Now this is about alternating current. Now, let us resolve this, guys. Try to think of this question, please. Just I connect to the electric here because it's very long. Okay, guys. Now, he said the graph, okay, shows alternating voltage. This is the potential difference in, and this is the time. The resistance here, we have R. Determine the equation for V in terms of T. What is the equation? The equation is V equals V naught sine omega T. This is the equation. V equals V naught sine omega T. What is omega? It's 2 pi over time period. What is the time period? It is the time of one oscillation. From the graph, the time period here is 0.04. Then, first of all, we calculate omega. So omega equals 2 pi over T. It's 2 pi over 0.04. If you use the calculator, 2 divided by 0.04, you will get 50. So it is 50 pi in terms of pi is it. Now the relation is V naught is the peak value of the voltage, which is what? It's 200, the peak value. This is V naught. Then the equation is V equals V naught, which is 200, sine omega T, it's 50 pi multiplied. This is the equation. Now find RMS voltage. VRMS equals V naught over square root of 2. V naught from the graph is 200. So it's 200 over square root of 2. The value approximately 141.4 volts. The average voltage, take care, the average voltage and the average current is 0 because the current up is the same as down. So the average is 0. So the average voltage and the average current, take care, it is 0. What is the average power? The average power is what? Is half, okay, maximum power. So it's half. The maximum power depends on the maximum voltage. The maximum voltage is V naught divided by R. So the maximum power is V naught squared over R. Why I use the V naught? Because it's already given in the figure. So it's half multiply 200 squared divided by R. R is 50. When you calculate this, it becomes 400 what? Question? Yes? Yes? Half? Why not half multiply V naught? No. The power I explained at the beginning. The power, okay, equals IV. When we talk about maximum, we write V naught I naught. The average power is half V maximum. So we don't use half. Okay? Yes. Just to check these for what? For C? For what do you mean by C? No. There is no C here. Okay? For part C, the average, okay, we take half zero, for example. No, my friend. This is the correct answer. Let us discuss when we finish. No problem. I will give you time to discuss, to ask me. Now, question number 26. He said, a bridge rectifier using 4 diodes as shown in the figure. Take care for this part. He said on the figure, circle the diodes, there are 4 diodes, conduct when point B is positive with respect to the point A. Now follow me. This is B now is positive. Then A is negative. Now the current from B cannot go back because we have reverse diode. Will be go right. Can you see? Right this. Cannot be go left because it will be stopped. Then this diode will take it because it's a circle. Now, the current go through what? Through the resistor. Now, the current do not return back to B. You need to go to A. Then, this also with us. Finally, to A. So, this is the circle of the 2 diodes. Now, on the figure, draw the symbol for capacitor. Capacitor is always connection parallel to the resistance. Then the resistor will be connected parallel to what? To the resistor. At any position, but must be parallel to the resistor. So this is the capacitor. Next, what is the function of the bridge rectifier circuit? Of course, to do rectification. Yes, question? Yes. B as positive because he said that. He said B is positive. Okay. Because this is the question. When B is positive. Because this is the question. Okay. Now, next question. Now, yes, another question. Yeah. Second like diode. Second like diode. What do you mean by second like diode? Because actually the diode allows the current to pass in one direction. So again, if the current in this direction and we would diode like this, so the current will pass. So this is forward. But if the current is opposite like this, so this is reverse, not pass. Okay? So the current will not pass. Okay? Because the first one is forward, the second one is back. Convert AC to DC. Okay, we can say that, no problem. Convert the AC to DC. Yes, that's correct. Yeah. Now, next question, part D. He said, the figure showed the variation of output voltage with time across the resistor. Resistor, can you see? We talk about resistor. What time interval during which a capacitor is charging? Charging when it goes up, like this. So this is a charging. Also this, charging the capacitor. So the time here from T1 to T2. From T1 to T2. Now, another capacitor of capacitance double. So when the capacitance increases, what will happen? It will be more smooth. So here, what happened to the ripple? It will be smaller. So, well, because the capacitor makes smoothing, become smaller. Okay, ripple decreases. Now, another resistor has a small resistance. The function of resistance to increase the time of charge and discharge. When the resistance less the time, it will be more. So the ripple increases. because the time will be more. The time it will be less because the smaller resistor. Yeah. Yes. Again, the resistor affected to what? Affected to the time of a charge. So this is affected, okay, to time. More R, more time. Less R, less time. Okay, so smaller resistor, it means a smaller time, so the ripple increases. Okay. Now we go back now to what? To the MCQ. Yes, Mr. If the capacitor is healthy, ripple increases. Let me check with you after the exam. Okay. Yeah. Now we finish the extended. In the exam, you take about 2 minutes break before to go back to MCQ. Now I advise you to take just 1 minute break like me. In that break, just drink water and just close your eyes. Do not think of anything to refresh your mind. Now, always repeat the dua. رب اشرح لي صدري ويسر لي أمري. اللهم لا سهل إلا ما جعلته سهلا. Always use that prayer before to start any question. Okay? Because remember, يعني وما توفيقي إلا بالله. Now, okay, guys, we go back to MCQ. Let us we do. Take care for MCQ because some of questions will be difficult in MCQ. Now, this question is said a voltmeter connected between 2 points B and Q. Look, B is positive and Q is negative. Okay, the reading is 1 volt. So this is reads 1 volt. What statement is correct about this? Now let us we think of this. He said, the energy needed to move. By the way, in the exam, you will get 4 choices. 2 of them completely wrong. And 2 of them, 1 will be correct. So take care. You can skip 2 choices of each question. The energy needed to move 1 coulomb of charge from B to Q may be correct. The energy needed to move 1 coulomb of charge from Q to B may be. The energy to move 1 electron, no, stop, this is wrong. Move 1 electron, no, 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 not 1 electron. Now we talk about A and B. Energy needed to move 1 coulomb from B to Q, no. The energy needed to return back this 1 coulomb in opposite direction. So the correct answer is that. Now, question number 2. He said the current in the circuit is 6.4. Yes, Adham? Yes, Adham?
Mister, does the charge go from negative to positive or positive
This is
to negative?
positive charge. No, that when we carry back the positive charge, look, this is energy needed to carry back. The energy needed to move 1 coulomb from Q to B, positive charge, okay, in opposite, okay? But it's already moved from positive to negative, okay? Now,
Okay.
yeah. Question number 2, he said, the current, we have given here the current, I. What is the number of electrons flow per second? So the time is 1 second. The number of electrons equals the charge over the electron charge. Q in 1 second, it is the current multiply the time in 1 second over the charge of electron, 1.6 times 10 power negative 19. So the answer is here 4 times 10 to the power 19. So this may be correct and this is correct, but this is wrong and this is wrong. Now, what about the direction? The direction of what? The direction of electrons. Electrons moves from negative to positive. So the direction, it's from Y to X. Then this is the correct answer. Next question. Okay, yeah. This question is important because talk about the relation between the power and the voltage. Remember, B
So can you go back to question
equals,
2 and disconnect it?
yes, yeah.
What happened?
Again,
Can you
question
explain it
number
again?
2. Number 2.
Yeah, number 2.
Yeah, number 2, I calculated the number of electrons. It is Q over E. Q is the charge. Q equals the current multiply time. He said per second, so the time is 1 second. And the current is 6.4. We calculated N. The N equals 4 multiply 10 power 19. So A or C are correct. The other are wrong. Now we talk about the direction. The direction of electron flow, it's from negative to positive. So the direction from Y to X, not from X.
Yes, so it's always negative to positive, right?
Yes, 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 yes. Now, here B equals IV, okay? So equals also V squared over R. Then B sometimes proportional to the current and sometimes proportional inversely to the resistance. Two light bulbs with different power are connected as shown below. Which of the following is true? Now, which one has greater current? Greater current if it has greater power, because B proportional directly. So the greater power here is this one and this one. Now, which one has higher resistance? Okay, now higher resistance here is 30 pi. So the correct answer here is this one. Now, next question. Here we talk about a mobile phone battery is charged connected to constant potential difference of 5 volts after 1 hour. 1 hour we have to convert to 2 seconds. Multiply 60, multiply 60. Slowly decrease. What is the best estimate energy transfer? Energy depends on a charge. It's Q times V. Take care. The energy of capacitor, it's a half QV, but the energy of any instrument, not capacitor, QV. What is Q? Q equals the area under the graph. This is a trapezium. What is the area? This one, and down it's 2, and the height is 0.5. So the area under the graph is half, open bracket, 1 plus 2. But take care, this is in hour, so multiply by 60 by 60, which is 3,600. So multiply 3,600, multiply the height, 0.5. Charge equals 2700 coulomb. Then the energy equals Q, 2700, multiply V, multiply 5. Then the answer equals 13500, approximately 1. So this is next question. Yeah. This is about EMF. He said V1 equals 7.5. From the voltage and resistance, we can calculate the current. Okay, by using Ohm's law. V equals I times R. So the current equals V, which is 7.5, divided by 3, which is 2.5 ampere. So the current is 2.5 ampere. What will be the value of the potential difference V? V is the terminal voltage. V is the terminal voltage. How can we calculate this? By using the formula. E equals I, R capital plus R small. EMF is 20, okay? But we can say it is V capital plus R because we don't calculate R capital. So IR, this is better. So we can say it's V plus IR. Now, V plus I, it's 2.5, multiply R small is 1. Then V, it will be 17.5. So this is the correct answer. Now, this important question about the relation in the potential. Remember that V over E, this is E, and this is V, equals the QB over QR. QB is the distance D. So, E is fixed and the QR is fixed, so V proportional directly to the distance. Then the relation is direct distance. Now, Next question. Here. He said a potential difference between the plates of capacitor increased from, I advise you to draw this here. This is for the capacitance, this is Q, and this is V. He said the potential difference increased from 18 to 34. The charge on the plate will increase by, so this is the change in what? This is the change in charge, 24 microcoulomb. And what about the change in volt? It is 34 minus 18. So C, the capacitance, equals the slope. The slope equals the vertical change over the horizontal change. So it is 34 minus 18 divided by delta Q, okay? Delta Q equals 16. So the answer will be 1.5 microfarad. That one depends on the right hand grip. So this is north here, then the answer is to be left. This also, it's easy. Here's the direction of the current here. Okay. Now, can you see? This is the direction of the current from the battery. Then the two currents have the same direction. Then it will be attraction. Then they move towards the wire. So this is the correct answer. Next question. It depends on the deflection. Here, this is Fleming left-hand rule because here out, so this is the deflection. Then this one is positive. But this one is opposite, so this one is negative. And you can calculate here, we know that MV equals R dQ. Then Q equals MV over RB. It means Q proportional inversely to R. Then QB over QA equals RA over RB. You can calculate RA and RB from the figure. You will get this answer. Now, next question here. He said, a circle loop of radius. So this is R. We can get the area. The area is pi, R squared. So pi multiply 2.5 times the 10 power negative 2 all squared. Okay. And this is the flux density B. And this is the flux phi. What is the angle? Actually, here when you use phi equals the BA sine theta, this theta is the angle between what? Between the magnetic flux density and the area. This is theta. But we need to the normal. Then we calculate theta and subtract it from 90. Now, phi equals BA sine theta. Phi equals 1 multiply 10 power negative 4 equals B. B is 0.625 multiply by times the 2.5 times the 10 power negative 2 all squared multiply sine theta. From this you can get theta. In my calculation, theta equals 14.8. Then the required theta is 90 minus 14.8, which is approximately 75.2. So this is the correct answer. Next question. Here, this is about what? About Lenz's law. Okay. Okay, this is here, a copper ring is placed as shown in the figure 1 and in figure 2. The magnet, okay, lies here and induced current follows the ring. Which of the following best describe the magnet movement? Now, here, this is the direction. So, okay, can you see this? So, by using right-hand grip, this will be north. By using hand grip, then this will be moved towards. And here, this is south. Already, this is the current, so this is the north. This is south, it means moving away. Then the correct answer here is part C, part D, because this is, depends on Lenz's law. Now, next question. They said NS, okay, this described ratio, NS step up. In the step up, NS must be greater than NB. It means NS over NB must be greater than 1. Also, the current decreases in a step up because the step up increases the voltage and decreases the current. So IS over IB must be less than 1. then the correct answer is that. Last one, it depends on the direction of current. Here, okay, if you take this current, for example, here, look, this, so this is wrong. Here, this is out, but here it said, okay, when terminal X is positive. So this is wrong because terminal X is not positive, and here this is wrong. Then one of that two, the right sides are correct. The first one is wrong. What about this? This is the current, 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 this is the current. So this is the correct answer. Now, guys, we finish the exam on time. I hope this lesson will be useful for you. Now, I advise you today, you have to decide now after the lesson which topic you need to do more revision about it. I already uploaded the 4 revisions on my channel. You can check, you can go back to my YouTube channel to review any revision that you want. I hope my lessons was useful for you. Thank you, guys. Thank you.
Thank you, Master.
Thank you. Thank you.